Good morning, everyone. This is Jim Giacchetta. I am CTO and co-founder of VidOvation. Today, we have a very special guest, David Bourgeois from CyanView. CyanView is one of the leaders. Good morning, David. CyanView is I want to jump right into what you do, David, but thank you for being here. So CyanView solves a big problem we have in production, and that is camera control. On a typical production, we may have studio cameras, field cameras, PTZ cameras, GoPros, high frame rate cameras. So you have dozens of different vendors of cameras. How do we control everything? How does a video engineer control all of this? So David, tell us how you solve some of these challenges. Tell us why we need to know about CyanView.
Thank you, Jim, for the invitation, and very happy to be there with you on this webinar. And definitely, I mean, we tackled camera control, basically working on high-end productions and meeting the request of having shading and control or specialty cams. That's where that's where we started. And that's actually developed, and now we're covering a lot of brands, a lot of models, and this is what I'm going to showcase here. You see the slides, right?
Yes, we do.
Okay, so this shows, well, we had for the beginning, I would say, areas of segments that we have control with. Those are specialty cameras, integration with the OB trucks, ENG cameras, and digital cinema. It's tended to develop, I mean, and evolve into 6 more segments, and mini cameras is definitely one. You don't necessarily, I mean, most of the time you don't have an RCP with mini cams, and it's difficult to get that in the workflow that you're using in live broadcast, and this is where we started. We added PTZ and now robotics. That means pan and tilt heads that we integrate more and more. When you are in a broadcast truck and you have color correctors, we integrate with them as well, in a way that we had the RCP there, and some of those specialty cameras you cannot get control on, and you're using a color corrector to still be able to paint them. And that's actually where we said we can put that on the RCP as well. And then we have ENG. That was not really the goal to control the main Sony camera used on high-end events, but there are many situations where you cannot control them, and so that's where people wanted us to still get control on that. And the same for digital cinema cameras. We're talking about the FS5, FS7, I mean, from Sony, the Panasonic EVA1, on the Canon C200, C700 range. So these definitely, it's nice add-on to have an RCP to have control. And now when you take all this, you will now have the project that we're going to talk today about remote production. It's to control all of them, but over the internet. So that's the summary of all the things that we're doing. Now, what are our products? Our products are a bunch of, I mean, the different remote and small box that are used to interface cameras to do color correction, or to interface with GPIO or the different parts. And so with these modules, those are kind of building blocks that you can use to build your workflow and to say, okay, this is what I need to control, this is what I need to interface. So those are the physical parts, but there is a lot of software development that we did to integrate with various pieces of other equipment. This would be a simple diagram. So that's, you have the RCP, that's the main piece, which gives you all the camera control. And now if you take one of those mini cameras, they are going to be serial, but our system is all IP based. So the CIO is a camera interface that's going to take the IP control and interface that with any of those serial cameras. If you have an IP camera like a PTZ or a Panasonic ENG, in that case, you don't need an interface. It's just on the network and you can control it directly. So that's, I would say, the most simple workflow that you can get. Just put the RCP a switch and you can paint IP cameras. If you add the camera interface, then you can also paint the cellular cameras.
I have to say, David, the products are very, very well made. The little yeah, you see how there's a 1/4-20 screw thread on the bottom of the unit, then a 1/4-20 receptacle to put the camera on, so you can mount it on a hot shoe on the camera, or in this case between the tripod and the camera, just sandwich the controller there. And what they're made out of, like extruded aluminum, right? They're very rugged, very well made.
Yeah, it's a CNC aluminum indeed.
Yeah.
And yeah, it allows us to have a small block, but I mean strong and indeed, I mean, if you see the cable, it's short. It's an adapter to the Marshall camera. I will show you some other cameras. We have these kind of short adapters for any brand and model of camera that we control, and then you can of course extend that. If you want to put the CIO at another place, then we have extension cords, or a lot of customers build their own cables. We have all the pinouts available on our website, the support pages. Now, when we are talking about integration with a higher end production, this can get more complex, and this is one of the typical applications that we have here. On the left, it's still the same. I mean, you have cameras, IP cameras, or serial ones interfaced. Everything goes to a switch. I mean, usually stage boxes today have a LAN port, or you can have a media converter, a switch with an SFP. On the truck side, or the control room, this is where we have more software. So you still have the RCP there, but we integrate with routers in a way that whenever you have, let's say, 50 cameras, we go up to there. You control 50 cameras on a production. Then you want to be able to synchronize the router and the RCP. So whenever you're going to select the camera on the panel that you see on the right, you would pick any signal and camera. The RCP will track that and will automatically select that camera, so you can immediately paint it. You don't need to select the camera on the RCP itself. Now, if you select the camera on the RCP, then it will synchronize with the router again. It will control that and just switch your monitor so that you actually are going to see the camera that you're painting. So it's both ways, and you can just, it's like the preview that you have on the standard RCP, except that because we control many cameras on one single RCP, we need multiple previews, and so that's the way that we do it. Whenever you click preview, we know which camera has been selected on the RCP. We request a signal on the router, and the other way around. When you select a new signal on the router, the RCP will just know which camera it is.
Yeah, we were talking about this. I was talking about this with you, David, but also with a customer yesterday. I've done some video engineering. I volunteer, well, before COVID, I used to volunteer every third Sunday as a video engineer, and Saddleback Church uses Sony cameras. So it's an 8-camera production. So there's 8 Sony controllers, CCUs, eight sticks, as you were calling it. So I mean, I either press on the joystick to pick what I want on the monitor, so that syncs with the switcher, or I press the buttons on my switcher to paint. So you eliminate the need to have a stick or a controller per camera, right? It's kind of overkill.
It really depends on which kind of productions, but definitely, I mean, especially with the mini cameras where we started. So, I mean, if you have 20 mini cameras, it makes no sense to align 20. You have no space in the trucks.
Right.
If you're talking, I mean, the Super Bowl or the NFL, our system is used now also to control the pylon cameras, and you have 12 of them. You don't want to put 12 RCP there,
Right.
because and so the way it works, you would just indeed pick the camera you need on the router panel, and the RCP will just select it. And for mini cameras like this, it's very, very convenient. You can still align 4 RCP if you want to control 4 cameras, and I would say this makes sense whenever you still with 2 hands want to control 4 cameras at the same time. So you are going to look at a multi-viewer. And in that case, if you want to be able to lively paint those 4 without having to switch or to do this, This is a way where it makes sense to have RCP. I will come on a slide just explaining another type where it makes sense. But when you're talking about many cameras, or even I mean PTZ, or having different kind of if you have too many cameras and you are not going to paint both, I mean 2 or 3 at the same time, we made it actually very convenient to just get one RCP and paint them all just sequentially. I mean, we developed that on the 24 hours of Le Mans. That was one of the first projects that we did with the MP Visual in France, and we had like 40 cameras, onboard cameras on the one RCP, and we actually had 2 RCP, but we were 2 people painting them at the same time. So we could paint the same camera, but well, that would be no problem, but we just shared them based on the need that we had.
But you have the flexibility, so your control can coexist with the more traditional or the camera manufacturer's control. You can mix and match and coexist. And
indeed, you just work the way what you want. You can have maybe 2 RCP that you want there all the time with stick to one camera, and then have a third one that would cover all the other cameras.
Gotcha.
So this is still possible. And on the slide, you also see the color correctors. And again, if you have a bunch of cameras that you cannot control, let's say those are onboard cameras, you don't want to send control wirelessly to these, you're going to put an AGA or any kind of color correctors there. In the US, I mean, it can be Evers. It's in that case, we would basically control the color corrector from the RCP, so you can do that from your shading position. I mean, you don't have to suddenly go to a computer or to go to the small knobs that you have on the frame unit. So that's definitely one of the we have people just getting our RCP only for color correctors. They have no camera to paint. They're just using it because in an OB, when you have 16 channels of color corrections, it's still very convenient to have that
right
below the hands of video engineers.
Very cool.
So all that, I mean, to give you a couple of ideas of what people are using our boxes for, the different kind of applications there. On top tier productions, this is all about specialty cams. I mean, they have plenty of Sony RCP and Sony CCU day stations. There is nothing to bring in there, but we're covering everything else. And the picture tells it all. So this is I would say the only other RCP that you need to control mini cams, PTZ, well, high motion or other kind of specialty cameras that we have, your color correctors. Robotics, we're starting to integrate more and more pan and tilt heads because some of them are not really IP or you want to synchronize that with the camera. So that's also something that you are adding in our workflow. Wireless is, we'll talk about that a bit later, drones. And CCU is actually, it's not really a CCU, it's a color corrector, but it's our own. We developed it in a way that it's more, it has the functions of a CCU, like detail, a multimatrix, and these kind of things. And the reason we developed that is to be able to match cameras. If you're taking most of the standard color correctors, they have a proc amp, so a video processor inside, which is a legalizer, and you can normalize the signals. You can adjust the blacks, the gamma, the white to make the signal clean, and the white would be white. But if the red is pink, you cannot take the red and put it in the right place. It's impossible. If you take 2 different cameras would have 2 different sensors, it's impossible to match them. And that's the reason why we said we need to develop something that will act more like a CCU, that will allow you to have the controls you need to match cameras together. And I will just show this right after. But I would say some of them are still projects that are going on, and we're working with these companies trying to figure out the right way to do that. But mini cameras, PTZ, color correctors, and our VP4 units are definitely products that are getting mature now, and that you can easily put in place yourself. The other ones are still projects that we're working closely with some big companies there. Now, so those are for the top tier productions. Now, if we move to smaller productions, in that case, they don't have these system cameras, all the Sony cameras and so on. So they're going to take ENG cameras, camcorders, and they're going to have live productions with this, even digital cinema cameras. And in this case, we're actually not controlling the specialty cams, but the main cameras of these productions. So those are going to be compact camcorders, the bigger ones, digital cinema, as I said, Sony, Panasonic, Canon, Blackmagic, we added that as well. And you can still have mini cams. I mean, Marshall, Dreamship, IO Industries are used there. And for robotics, we also integrated gimbals. So if you put a gimbal, I mean, a Marshall on a gimbal, or the small pan tilt head from Marshall, we integrate that as well. So those are a piece of equipment that you can now control from our system. So that's really a different setup. In that case, you're saving money, but mainly you would normally not have an RCP. You would not have control on this camera. So it's basically adding shading capabilities now in these small productions, while earlier you would basically do that over the comms, having the intercom, asking the camera operator to put a bit more red or blue. Now it's an easy way to still be able to paint everything. And if you have like a car to fly back or something like this, and you have no space, this is where it makes a lot of sense to have one RCP to control everything.
Very cool.
And then the third, I would say, different type of applications that we're doing today is remote production. And that came, I mean, we developed that even more this year with the situation with COVID, but we started earlier. And that's really taking all the cameras that we control, everything, but now you want to control that over the internet. Or you want to control that on a motorbike if you're doing a cycling race or a marathon, and you have an ENG camera, and there are so many, I mean, you're going to talk about AVWest, but so many video transmission using cellular today, that it was, the next step was to be able to have camera control there with these kind of situations. And so on the top left picture that you see there are 4 RCP, and this is a remote production where they would do multiple soccer games at the same time. And we have 4 RCP there. All the games are 4 cameras, and if you select game 1, the 4 cameras are going to take the 4. So the 4 RCP are going to take the 4 cameras of game 1, and there might be 4 Sony cameras. And then if you select game 2, then the 4 RCP are going to swap to the 4 cameras of game 2. And so you have like a multi-viewer in front of you seeing 3 games at the same time, and you can just select the game that you want to do, and then you have the 4 RCP to paint them. So that's another situation.
Well, and the important thing too is that your appliance on the far end, when you switch, the camera doesn't lose its settings. So it stays, the iris and the black stay where they're set, correct? When you jump from game to game to game or camera to camera, correct?
Exactly. So the RCP is just saying, no, I want to control this one. But actually, when I say it's a complete architecture, there's all the cameras are still controlled all the time. It's not because the RCP is not actually actively controlling this one, that's the system is still controlling it. And you can have like another RCP, you could have another kind of interface which actually just still can control the camera itself.
And there could also be you could have a backup operator working from home or another location controlling that camera. So the workload could be shared amongst people in different locations. That's why this has proven so valuable during COVID and lockdown and social distancing, correct?
Indeed. I mean, you can control that over the internet, as I said. You could also have an RCP locally. It depends on the kind of production. And then remotely, you can control that. And now we are adding the possibilities to have a completely distributed architecture in a way that you will be able to put an RCP at any place to control anything. I would say you might have multiple productions at the same time, and from one RCP you will be able to control them all, but you might also have a second RCP at another location, or like you say, from home, and still having paint control on all these cameras. And not only paint, I mean, if you want to move them, framing, these kind of things can be done as well.
Very cool.
And so those are, again, all the cameras that we support, but now used for REMI style productions. This one is just a slide, to showcase a lot of brands that we're integrating, a lot of specialty cams, because that's where we started. There are a bit less of ENG, but that's what we're working on at the moment. So we have Sony, Panasonic, Canon, Blackmagic, and we are going to soon add support for Grass Valley, Ikegami, and JVC. All the other parts are quite developed, and we need to add a bit more color correctors, but we have quite good of them already. And so that's again.
Go ahead.
No.
Well,
so that's
what was I going to say? In our experience, that shading of cameras, some people just say, well, why don't I just stick the controller into the public internet or into the network, and why won't it just work magically? Some camera systems, what we found, and you can correct me, David, they're very sensitive to latency on the network. So if you go through the public internet or you go through cellular, the RCP in the camera will time out if there's more than 10 milliseconds of latency or 5 milliseconds of latency. They're really designed for being in the same studio on the same network, right? So your technology smooths out or really gives the ability to communicate over the internet, correct?
Exactly, and maybe I will come to that a bit later. Here is exactly what you're saying. I mean, the CIO interface is going to take some IP packets and send that to the camera. And those mini cams are serial based, and serial based means that they receive some data. They are going to send the data back maybe, less than 1 millisecond after. So it's very quick. And if they're asking, requesting something, and you don't answer, if there is a kind of acknowledge system in place and you don't answer to that within a couple of milliseconds, they would just reset the connection or these kind of things. Or like a Sony camera will basically go back to its own. If you take a camcorder, that's normally a camera that you operate from. The cameraman himself will operate the camera. So all the settings are done through the menu or the knobs of the camera. Now, if you're controlling it remotely, you plug the cable in that. If you don't answer to the acknowledge of the camera, it will just think that the RCP is not there anymore and comes back to its own control mode. And some of the cameras just change settings completely. So you're losing all the painting that you did with the RCP. Suddenly the iris goes weird and these kind of things. So definitely controlling cameras locally is what you should start. But when you're talking about going over the internet, even though everything is IP, it's not the same story at all. It depends on which protocol the cameras are using and if they've been made. But I know no camera today that have been made to be controlled over latency networks and the internet. They've never been designed like this. It's only right now. I would say I know companies like Panasonic, Grass Valley, and so on have their own solutions today for remote productions, and it's really adding layers to what they had already or redesigning that completely from scratch to make their system work. And what we did, I will explain that later on with Rio. What we did is take all this kind of local control that we have and bridge that over the internet. So the camera still is controlled locally, but we can put the RCP wherever we want.
Right.
I will explain that a little bit more on another slide. Right now, this one is really on local control. So let's say the RCP, you have a couple of switches or local network, and you want to control these serial cameras. You just use this CIO interface and connect the camera, and you get control very quickly and easily.
So the CIO you'd use on the local network, and the RIO, which you're going to get to in a minute, that you would use over internet or over cellular, or if there's some latency in between the camera and the RCP, correct? Exactly.
You should be able to see, the CIO is quite advanced in the number of protocols it supports. So we support LANC, we support S-Bus for gimbals, we support, different kind of proprietary protocols that we have in there. But otherwise, so translation is quite complex, but you should be able to see that like a USB converter that would be from USB to RS-232. This one is IP to a lot of serial protocols, but it doesn't have any intelligence in a way that it doesn't know what it does. It doesn't know that it's gain or something. It just receives a packet over IP and put that on the right electrical interface for the camera. So it's been designed to support all the protocols that are used in broadcast. That's what makes it very different from just out-of-the-shelf IP to RS-232 converters or these kind of things, because we are still going to add specific things depending on what camera it is. If it's a Sony, if it's a Vizcar like Marshall, IDA, and so on, we're going to do special things to make sure that it works well. But beside this, for you, you can still consider this is an IP to serial interface. Rayo is like a computer, which also has an interface built in, but the major part is the software running on it that will just handle all the protocols that we support. But yeah, so I can maybe do a demo of this to show you. I mean, you have one of those typical, I mean, Marshall, Dream, GPIO Industries, a lot of them, or maybe a Sony block. And you want to control that. So let me switch to this. So there is latency there. I was waving my hands, but yeah. So you will see a bit latency in the video, but I mean that's also here on my desk. I have the RCP. I will switch to the other one here so that you will see the RCP there on the right. What I'm doing here, and then I have a couple of mini cams here. I have a Blackmagic router. I have our own VP4, so that's our video corrector, a PTZ from Panasonic over there, and yeah, I will first. Let's say I'm going to take this. This is the Atom Mini from Dreamship. We have a Marshall, we have an IDA camera, and the IO Industry here. They're all configured there on the system. And so right now it's running, but let's assume that it's actually not configured at all. I will go show you the configuration interface here. So the Atom camera is this one. I'm going to delete that one, and we are going to recreate it. So whenever you have a new camera, you well, I screwed that one on the, as you see on the CIO, there's a screw at the bottom as well, so you can put that on a tripod. I screwed the camera here. We have those cables that are adapters that I will plug on one of the ports. So the CIO interface has two ports, port 1, port 2. And I'm connected on port 1 right now, and the serial number of this one is 12110. So the cable is actually going to power and control the camera. So both go in that. So the CIO is PoE. I just have the Ethernet here. The other cable is the video, 3G SDI. So just one Ethernet cable, PoE, powers the camera, controls the camera. And well, actually, you still see the configuration interface there. So yeah, I was just repeating a bit myself, but this is the camera interface here. This is the cable, so you just plug the cable in one of the connectors here. This is the PoE cable that drives and power the camera. So you see now if I just plug this, it's going to start. If the version doesn't match the one of the controller, that's going to be bootloaded automatically. So you don't really have to handle any update of these boxes. They're going to be kept up to date all the time. And now I'm powering and controlling the camera, but I need to configure that. So to configure it, I go to that configuration interface here. I click on the plus sign here to add a camera. So that was my camera number 4. I put a name, it's an Atom camera. I will select, these are all brands that we support today. I mean, so some specialty ones like ARC in UK, RE, ADMEC, IDA in the US, AJA, Burdog, Blackmagic, CIS, Camera Core in the UK, Canon. So there are some very known ones. Cyan, we don't do cameras, but we have a kind of generic protocol. So if you want to use a generic camera and develop your own interface, you can do that. Dreamship, Hitachi, IO Industries, Lumens, Marshall. Panasonic, Ross for the pivot cam, Sony, Toshiba, which is now owned by Canon, Vision Research, Yoshida. But here I have a Dreamship, so I select Dreamship, and in that case, I have the list of models that we support. First one is the Atom Mini.
Are you frozen, Dave? Well, maybe we couldn't see the drop-down menu. For some reason, it's not visible.
Okay, yeah, it is actually possible that the drop-down don't show up because.
Well, yeah. So what David did there, you see on the right, kind of middle, where it says brand. He clicked there, and I've seen it myself. There's a long list of about 30. You pick the camera manufacturer you want, and then it automatically sets the protocol pretty much, right?
Yeah, I will just share the complete screen. So let me get that out of the way. If you see the screen right now.
Yeah, we see the control screen, yeah.
And you should now see the drop down.
Now we see it. Yes, now we see. Yeah, that's very impressive. So you see, folks, all the camera choices are there. So if something is missing, you can create your own protocol. If you know how to configure it, you can do it manually.
Now, if you take the Cyan, that is a generic protocol. I would say if you're a developer, manufacturer of some specialty cameras, and you're looking just for an RCP that would be able to be used to control your own cameras or to do anything you want, then you can use that model, and there's an API that comes with it. And so you can see the values changing on the RCP, and you can use that to interface your own equipment. But otherwise, if you're using a camera in broadcast that we don't support, this is the way we added so many, is that our customers are just saying, okay, we're going to use this one. Do you support it? We say no. Is it possible to have the camera? And then we do the development and we add that protocol. So the list, I mean, has been growing.
You don't sleep. You don't sleep. All you do is write camera protocols.
Exactly, but I mean, yeah, we were a team, so there are a couple of. I mean, we share that, but yeah, I'm part of this, and then there is mainly one person behind all the protocols and handling all that, and it's a challenge somehow because all the protocols are different. They don't work the same at all, so it's quite an adventure. But yeah, the list has been growing in a way that at the beginning we just had the models of camera we support, but that was like 3 pages long. So we had to split that by brands and manufacturer. So now you select Dreamship, then you have the list, the models that we support from Dreamship.
Perfect.
They have more cameras actually, but most of them are in you use the same protocol as this one.
Gotcha.
So here I select the Atom Mini. So that's the way you have any camera. You take the brand, you select it there, you select the model, and then you need to decide on which interface that is. So now if I go to interface port, I set on the CIO that I have here, it was 12110. So this is the one that is here. And then I have 2 ports, port 1 and 2. I connected on port 1, so I'm going to select port 1.
Now let me interject. So that 12110 is on a sticker on the bottom of the device, correct? That's how you know which. You mentioned having 50 specialty cameras in production. Which CIO do I need to talk to? Right, the number. It's part of the serial number, correct?
Yeah, indeed. And on this camera, let me go back to the. I did share my full screen. I need to come back to the
individual screen.
Yep, there it is.
Oh, you took the OBS output.
Yeah, indeed. So I can also show the output of the camera there. Yeah, so we have this. There's just one thing I forgot. Let me. Okay. Yeah, so I will just rewind this. Back to the configuration interface that you see here. Yeah, okay, you see it. So let's say I will select the other port. I'm on port. So I'm on port 1. I will just select port 2 right now to show you what happens. So it's the wrong port. So what happens on port 2 is the camera is red here. If you look at the RCP, I will go to camera 4 that I added. So now I have camera 4, the atom, and you see a red icon on there as well. And we are going to see that. I will show you after. We have a stream deck here that also shows the number 4 on the atom. And on the CIO, I can show you that right away also. If you look here on the CIO, you see that on the right, I have a small number 4. And on the right, it doesn't work because I didn't connect anything on the right. So now I'm going to go on my configuration again and change that to the right port. So as soon as I add the right port, so now I selected port 1, you're going to see that
it'll go green.
Exactly, it should come green, and this is actually where.
Give it a sec.
Yeah, no, it will just that this camera is not the. I should have selected another one. This camera is in 9600 baud, while the default is another one. So I need to change that. But yeah, as soon as you connect the camera, it turns green here. And if I do actually come back to there, you will see that the number now is on the same side as the connector, and we have a big 4 here, meaning that the camera has been detected. And if you look at the RCP, it's green. And if we look on the configuration interface that we had there, it's green as well.
Oh, another cool thing I noticed. So obviously a studio camera will have a tally light. David has tally lights on the edge of the little box. So a little specialty camera doesn't have a tally, right? So you can can light the tally on the box.
We have, if you go to the tally, I can force it to on or off on.
It's kind of hard to see.
Yeah, it's hard to see, but actually it's there. Just on my finger there.
I see it. Yeah.
And so I turn it off and on. You
Yeah,
can also add an LED on the side. We usually use the second port, and then you put an LED and you put a lamp or anything that you can control that way.
Oh, so you have what, like a GPIO output to control a bigger lamp if you need it, a bigger tally light?
We have GPIO, but you are also going to use the 12-volt output that we have straight there to power the LED directly. So that's kind of easy. I have actually one there. I will show you it after, but it's a small connector. I put an LED on that. I connect it there, and then you can use it. So now it's on, but I can use it for tally.
It's much more visible. Yeah.
I can actually show that right now because we're talking about this. If you go to the GPIO page here, and so that's my camera 4 atom here. So I can also turn on and off the tally here. But now what I want is to put, so my CIO is here and port 2 power is here. I will just click in there, which will mean that now I have a red tally signal that is going to drive the LED. So you see right now the LED, you don't see, I will switch back to this. So if you see the LED is off right now at the moment, and if I turn on the tally again, you see the LED is on, off, on, off. So I can, well, that's all you need to actually decide that this kind of signals, GPIO should be linked to the tally of this camera.
Well, and then obviously you have the configuration ability to tie this into your production switcher. So an operator's not, you're just doing it manually right now because you don't have it programmed into, you don't have a production, it's not programmed into your production switcher, but you certainly can do that, correct?
Yeah, we actually integrate with some protocols already. We're going to add TSL, but we have that. It can come from a router, but mainly a switcher like an Atom. TSL will allow you to come from anything. We also have GPIO, so there is one that comes. There is a GPIO device that plugs to the RCP, and we have a new device which is called Neo, which is a network IO, and will allow you to have up to 16 GPIO on an IP network. And we have a picture of that on the slides a bit later on. But yeah, so that's basically, so this interface I showed here is to configure some GPIO to act like a tally or green tally or a core signal or any kind of GPIO you could use to do something else. We had some customers actually using that to trigger wipers on some of the cameras used outdoor and these kind of things. But yeah, and after that, if you have the GPIO, so those are the inputs. If I plugged one of the interface, I will have a lot of inputs here that I could just basically use this grid to say which input should go to which output to control tally. So that the configuration is done at the same place here. So back to the to this example, I mean, so that's basically now you see the camera is green. I have control on that, so I see the value. I can change the gain on the RCP itself. I'm not sure actually which signal we see on the router, just because I didn't configure the router yet. So if we go to the router configuration, I have a router which has been added here. If you want to add a router, you go to the plus, and then we support, I mean, the video hub, the ATEM, Evertz Quartz, Probal. Probal is going to cover a lot of routers like ROS, VSM, Cerebrum, those are management system. I guess TSL should be there as well. So you just add a block there, and in the properties of that one, you put its IP address, then you select the number of inputs you want, the number of outputs, and you will not see the drop down, but that in that line 9 there is unconnected, and this is where I had the atom connected. So I will just select in the list atom. You will see it now. I selected atom there, and which means that now if I press on the preview button, you just saw that the signal there on the top changes. So if I go back to another camera like the previous one, and I come back to the atom, now it actually knows to which input signal it is connected, and there we have it. So it's a pretty dark picture. This is where we have no arrays, but I can put a lot of gain there. I can go to the camera white balance and trigger an auto white, while on that one with with a little bit of this kind of signal.
Okay.
It's
so you went into the router settings. You did it kind of quickly. You went into the router settings. Then there was a list of inputs on the router. I think so. You said number 9 was it added it said unconnected. You went in there, pulled a little drop down, then you connected the camera you wanted on that input. It was
exactly.
It's that simple.
Yeah, and so so here I will just do it. I think with the strong lighting that I have in front, the auto white balance is not doing great, but I can do that manually. So I have my I mean, red gain, blue gain, the black levels, black balance, and then on the main page here we can change the gamma, we can change the saturation, we can change the detail. And the filters when this is supported. We have scene files. Scene files, I mean, you can load, save, and 0 is the default. So when I press apply, I'm just loading back the default settings from the beginning. Another thing which is quite different on our system is that you can basically load or save all cameras at the same time. So if I click on all, then I have multiple slots, but when I press on apply there, it's going to save and recall the settings of all the cameras at the same time. And so if you have 20 cameras, you want to save that, you just save all, and it's instant.
You don't have to go into each one individually.
Exactly.
You have 50 of them, not 1 save, 2 save, 3 save, just saves everything. That's very powerful.
Auto, I mean, I can trigger the auto exposure. I can go back to manual. In the paint menu, we have gamma, black gamma, saturation, detail. Not all cameras actually support all that. So you see when the detail frequency and coring are not available on the Dreamship camera. So we just put dashes here. So you know that these settings are not supported by this camera model. And on a lot of functions, we now try to add turn on and off, so you can see the difference, what it does, even if the camera doesn't have an on and off. And we have a Paint 2 page for some of the things like the matrix that you can change, the multi-matrix. I will come to that after. Knee, white clip, skin tones, like on the Panasonic PTZ that's available. Under the camera, there's OSD. I will show you that with maybe the Marshall. Exposure index, white balance, tally, I show that, and then some custom buttons depending on the functions that we need there. And lens, there is nothing on that one because we don't control the lens, but with a PTZ, you will be able to do a couple of things. So, I mean, that's it. If I can show that, I mean, one more time, I can, we have 2 ports on the CIO. I will just plug the IO industry on port 2.
So you don't need to buy another CIO. If you have another camera nearby, you just plug it right in.
Exactly, and after, I mean, you can put 2 cameras, and depending on the protocols like Marshall, Visca, Dreamship, and we'll probably support IO Industries as well. We support a bus of cameras, which means that if you have already a kind of bus, you should be able to go from one camera to the second to the third, and you see the features there at the bottom that we have in the configuration. This is a new functionality that we developed, and then we have a couple of buses there. So to support a S-bus for gimbals, Visca, Blackmagic also, we can support multiple cameras on one interface, and Dreamship. That is going to expand. I had an IO industry here. I will just configure again. I will select interface. I connected on port 2. So you will see that now I selected port 2, this appears, and hopefully, yeah, the camera turns green. And now if we go back to the...
It just went green.
Exactly. Oh, so that's the delay on the video, yeah. So well, I'm not sure you will see, but now we have 2 numbers. We have a 4 on the left saying that camera 4 is being connected there. We have a number 2 there on the right saying that the camera is there. And so if I go to my camera 2 here on the RCP, you see that it's an IO industry. The icon is green now on the RCP. What I want to show actually with these icons is...
You need to open the iris on that baby. It's very dark.
Oh, yeah, indeed. I mean, it's just... yeah, that's the right camera indeed. And I need to put...
Pick number 2.
Yeah, there we go. And what I would like to, what I wanted to show is that sometimes you don't know, is the camera powered, is it working, do I have control on that? And so if you disconnect it, you will see that actually it will go red. So you see the red now on the RCP. You see also the number here has turned small. So whenever you do the setup, you plug the camera on the CIO. If it's configured already, you will see when the number is big, you know that it's working. And on the RCP side, when it comes green, you know that it's actually working as well. Yeah, so that's a way. I will take, I mean, this is the IO industry. On that one, you also have OSD. You can enable the menus there. I know what happened is that I manually turned the iris there. So it was quite dark. And so you can go to the OSD, you can change a lot of things in there. So all the settings that actually are not available for the protocol, or we don't necessarily support because some of them might make no sense, then you go to the OSD, you can put that there manually.
So I'm not aware of any camera control system that will go into the OSD of the camera to go deep into the camera settings from the engineer workstation. You usually have to go to the camera and do those types of settings. You know, if you want to change the gain or something, or the shutter speed or something like that, you can go. Can you do that with every camera or some cameras?
All the cameras that actually do support an OSD, like I said, the Dreamship, they don't have, and they probably don't need. They're having like a software on the side. But if I take the IDA, for example, here, I go to camera menu, and then I can navigate the menu. You see from the, we even assign that on the the encoder so that we can more easily go and jump into some menu and turn that off. If I go to the Marshall, that's basically the same. I have also a menu structure where I can change this. I'm just going to wait for the video to catch up.
That's extremely powerful. That you know, particularly if you're going to the public internet or cellular, you know, maybe if you had a computer on the network, some of those functions you might be able to get to, but every camera would have a different configuration, a different setup. So you can bring that up right on the remotely from the video engineer's workstation. That's amazing.
Yeah, exactly. And again, if you're taking like a camcorder, digital cinema camera, a Sony FS5, FS7, the Panasonic VariCam, the Canon C200, they have a lot of menus. There are a lot of options there that are not available on the protocol, and so you can basically go and change everything from there.
Very cool. Very cool.
Again, I mean, I will show that on the PTZ, but maybe it's the right time to show you this. So those are, I mean, it's a bunch of cameras we have here that we control on minicams. But if I go to PTZ, that's basically the same. We support a lot of them already. And so how does it work when you configure an IP camera now? Is it as simple as that? It's actually even simpler. So if I come back to the configuration that we have here, I will select the Panasonic. It's already configured here. But the thing that you do is you select the brand Panasonic, you select the model. We have a long list of model. I will just, yeah, probably 20 entries there, or the PTZ model, VariCam. So you don't see the drop down, but basically,
No.
all their, I mean, P2 camcorders, the EVA1, and the old serial P2 as well that you support with a CIO. And there on the IP, we have an auto discovery with Panasonic, so some of the IPs are going to be filled automatically. Otherwise, you just put the IP of the camera here, and that's it. I mean, you don't need more than that to get control on the camera itself. And
so Panasonic, you auto discover, or just have the any PTZ camera that's on the network. You punch in the IP. Will it automatically figure out the brand, or you have to program the brand and then put the IP in?
Yeah, no. So you select the brand and model, and after if the IP is discovered, it will be selected automatically.
Okay.
This is something that will probably evolve along the years, where we're going to add maybe more kind of discovery, listing all the devices that are discovered on the network, so you can just select the ones that you want to take into control. I mean, it makes sense for PTZ because some of the productions, they have many of them, so it will save time. But I would say today, just this process is quite straightforward. When you have multiple cameras of the same time, the same type, if you just select that camera and click on the plus, it will automatically create a new camera of the same type. So those are small things that we put in place to be able to save a bit of time.
Many customers are using NDI. Do you not need this capability if you have NDI, or do you work with NDI? How does NDI fit into the equation?
NDI actually, they start, but the controls are very limited at this stage. I mean, these controls of the pan and tilt and these kind of things are included in NDI, and we have we're going to support that as well at some point where we'll add this. But I would say even with Burdock and all the cameras, if you take Panasonic, Sony, that are NDI, today, at least today, the status is that the control protocols for the painting, I mean, shading or everything else, is still their own protocol. So that's not part of NDI. It's IP, so you don't need actually to put everything in NDI. You just, that's the same cable, it's the same everything, and you just use the protocol of Sony or Panasonic, Visca or anything to control a camera, while the video is being, instead of going through SDI, will go NDI on the same.
I see. So since the NDI camera control capability is limited, you would just use the NDI to carry the video, and then you would do the control of the same camera with CyanView.
Exactly.
Gotcha.
And
Gotcha.
but so it's completely independent, I would say, and this is fine. There's actually no problem to use NDI instead of SDI. The same way as we don't deal with the video on SDI ourselves, we don't deal with the NDI. That is going to be a transmitter or receiver, and we are completely on the side of that, doing the paint and the camera control.
Mm-hmm. Very
So
good.
yeah, there is absolutely no problem to use that with NDI. There's nothing special to do. You just it's actually easier in a way that you already have the IP networks with everything.
Right. If you have an NDI setup, you're already in the IP domain. So adding CyanView is a no-brainer then at that point.
Exactly. Yeah.
Okay. Okay.
Uh,
Do you have some slides to show us about the Rio? You know what the difference is of the Rio compared to the CIO?
Yeah, indeed.
Or you'll get to
So
that.
I will maybe just show you as well. I mean, I have a stream deck here. It's part of the many things that we do support is integrations. And so you see, I have the Blackmagic router over there. If I had the Blackmagic panel and I switch to the, so this is actually that's a Blackmagic Micro Studio that I'm using to as the main angle. But so you see, I did nothing else than select the camera. If I select camera 1, then I can change the gain of that camera. So that's the Blackmagic Micro Studio. If I select camera 3, I'm on the Marshall, and if I just paint that on the RCP, now I'm controlling this one. Sorry, that's the Panasonic PTZ. And now if I do exactly the same on the Stream Deck, you see that it's actually switching the video hub. So the RCP will switch that. I can switch between multiple cameras on the RCP. I can do exactly the same on the Stream Deck. I switch to camera 3. So now I can paint that camera. I can switch to camera 4. This is the Atom. I can paint this one. I switch to the Marshall and I can paint it. So I have nothing to do on the RCP, keep my hand on the knobs to paint it. And then I use the panel of the router or a Stream Deck on the side, or we also have like a switcher interface on the software that you could put on a phone or tablet. So there are many ways to switch cameras, and even as I said on the RCP itself. So on the RCP, I can paint that one, switch and paint another one. It's very quick actually to handle all that.
So I'm thinking Saddleback Church, where I volunteer, they have a few specialty cameras on stage. I think they need a CyanView RCP and a couple of CIOs to be able to paint those cameras. So get them to match. You know, the director won't take camera feeds if the video doesn't match the other feeds. They just won't use them in the production, or it's too obvious that you're going to, you know, if the pylon camera doesn't match the main stationary cameras, it looks awkward. It looks out of place.
And that was the starting point. I mean, you're talking about the pylons, but all I mean, the big productions where they're using many cameras, that's where they're struggling to get control on that and so on. And this where we said we need to do something good about that, and that was the starting point. And we kept adding, but really that is. If I take, for example, the Panasonic PTZ here. As I said, the next point for us, that's now you can move the camera. So you see I'm moving the camera here with the touch screen. I can also use the encoders. I can basically put in a certain position, save that. So I will save this position. And now I will click on another button. It's actually going. So I made a position earlier on the color chart. And I can recall different positions from the RCP itself.
So you don't need a joystick. You can control the PTZ cameras right from the touch screen.
Yeah, indeed, you don't need it. In some situations, you actually don't really need it in a way that if you're using the camera for framing, you can do the framing from here, or maybe moving between 2 positions. That's very quick and easy to do it from there.
Presets, so you're not panning it while it's live. You're just jumping from preset to preset, and you frame it before the production.
Yeah, what you won't be able to do is to do the tracking. I would say that's not. But in that case, we do support a couple of joystick options. I mean, the Visca ones. We have a USB joystick that is inexpensive and pretty decent. that you plug as well at the back of the RCP. It's USB, and then you have a joystick that you can use to just move the camera that you selected. I would say on the bigger production, I mean the productions that would have multiple, I mean if they have a joystick panel on the side, like Sony, Panasonic, Birdog, they can still, it's IP, so they still use it the way they do today, and they do the shading from the RCP. They can still move from the RCP, but that would be done from the joystick panel.
Yeah, I mean,
so,
in a smaller production, the video engineer might be doing the shading and running the PTZ cameras, but in a bigger production, it would be a camera operator that would be moving the PTZ, and the video engineer does the shading.
Yeah.
Different functions.
Exactly right. So that's the way it works. And so when you have many PTZ, you are going to have multiple camera operators. And but on the RCP side, you might have just one or two video engineers. It depends if the conditions change a lot or not. And again, this is what you can easily do with our system. I said that on a Panasonic, I mean, you can also go to the menu there. If you see, you can access all the things. So that's so again for all cameras.
Mm-hmm.
Yeah, so that's for IP cameras. I would say it's as easy as that. I'm not going to, well, we'll have an ENG right after with the Rio, but all those kind of ENG style cameras or the D-Cinema cameras are also available. You didn't see,
you said Ikegami and Grass Valley are coming?
Exactly, for the DNG, those are the ones that, and Rio, it comes with Rio where it makes sense. If you were on the local network and you had those RCP from Ikegami, from Grass Valley and so on, we have no added value. I mean, the people are not waiting from our system to help them. But where you're talking about remote production and you actually just want to have the camera operator with the camera head on site and nothing else, this is where it makes sense to integrate these cameras as well with our technologies, and so that brings us to Rio. This slide here, we went through that, so I explained a bit everything. What I didn't show is the color corrector that we have here on the slide of VP4, which is
so this is the CyanView color corrector. It's your own color corrector.
Exactly. So the reason we did, I mean, we control the ones that are available, as I say, 4A, AJA. There's a list, I forgot about that, but Lavo, and but the reason we developed our own is actually to be able to match cameras together. So as I said earlier, you can still paint the blacks, the whites, the gamma, the saturation on a standard video processor using the proc amp. But as soon as you want to match cameras that actually don't look together because they don't have the same sensor, the same brands and model, that's where it doesn't work anymore. And I can take actually this Panasonic camera here, if I can point it to the color chart. I have actually, so in the configuration, I can show you quickly on the there is camera 7 and 8. The camera 7 is the GoPro I have on the RCP, just to take, I mean, the view of the RCP. And camera 8 is post-processing. I did not have control, but I did add a video channel on the VP4 on that camera 8. You can actually combine camera control and video processing. The way it works is that if, for example, gain is available in the camera head, the gain will control the head. But if the camera doesn't have black control, then when you change the black, it's going to be done by the video processor. So it's really a kind of hybrid mode.
You can configure that. So if color balance is not possible, just you can do color and black. It gangs the functions together, whether it's in the camera or in the CyanView video corrector.
Exactly, and that would work as well. I mean, with AGA, 4A, all those other color correctors. The reason we did that is actually when a camera is lacking black control. I mean, some of the older marshals said that. That's the reason where when people are going to add a color correctors, they say, I need this control. If I don't have black control, it doesn't match. So they add a color corrector to just apply that. But we say it doesn't make sense to have two different cameras on the RCP. We can have the same and merge these controls. What's available in the head will be applied in the head. What's not available in the head, but available in the color corrector will be done there.
That's very cool.
And so here I actually just made a camera. I said there is no camera I had to control. So I have all the settings available from the color corrector. And so this is, you see that on the, the small, you see that on the main monitor. What do we have here? So the same thing, I have scene files. I can save, load as many files as I want. So I will just start by just resetting this to default. So that's transparent. I can change the gain. I can change the blacks, the black balance. I will just put that completely red. I have access to the gamma, and then I can go to my scene files and load defaults again, and that is going to reset everything. There's a little bit of delay, but I guess you managed to follow. So those are the corrections that you have in a standard color corrector. So nothing different in here. Now, if you want to match different cameras, this is where we had to add a couple of things. And so we see that in the paint one, for example, we have gamma, just like the other ones, but we have black gamma. So you can turn the black gamma on, put that to the maximum. And if you go with the on-off, I'm not sure with the delay you will follow, but you see the difference there. Saturation detail is definitely not normally available in some color correctors, so we can add more detail in the picture. But I mean, I will show the main feature. So we have a multi-matrix there, and I have a gate effect. So now you see the picture is black and white except one color, and I can change and can pick another color. So let's say I want to change the green. The green of the grass is not matching the main cameras. You have a mini cam in the goal, and the green is not matching that. So what are you going to do? I have the gate effect. I select the green. I can put more saturation. I can put hue. I mean, let's say it's not. It's going to be an ugly green, but just to show the difference. And if I remove the gate effect here, you see that the green has been changed. If I turn on and off, you are going to see that it's only the green that are going to be affected. I should basically, for the next demo, add a vector scope, because you will see exactly the colors that we pick and that we move.
So this is a homemade way of doing a vector scope, just isolating the green.
Yeah, exactly. This is what we did there. Maybe I'm not sure if you will be able to see it there on the Atomos, but if I turn on and off, you will see that only some parts are going to move and the other parts are not going to be affected.
When I was first, I was trained as a camera operator at Saddleback Church, and I go into the control room and I'm like, hey, you have a WFM Tektronix waveform vector scope monitor. They're like, you know what a vector scope is? You know what a waveform monitor is? You're a video engineer now. So I got promoted. I got promoted from camera operator to video. Well, not the camera operators have to frame the shot properly, but maybe my video engineering skills were better than my camera skills. Maybe I didn't know how to frame the shots properly, so they quickly switched me to video engineer.
But yeah, so you get the idea. I mean, I can take the GoPro that is shooting the RCP right now. I'm not sure if we are going to see the chart there. So that
there's a little piece of it, yeah. So you could ship it right from there.
And again, so the GoPro, I have no control at all on that. I mean, that might come in the future, but right now we don't. We did a proof of concept of that on Ninja Warrior, but and so I mean, if the red of the GoPro doesn't match, but I still want to use that, or an iPhone with NDI, you say you have an iPhone and you get the signal at your facilities remotely. Now you can pick that thread and you can add more saturation on this. You can change it to the red you like. So let's say I want to have a bit of that. And so you see now the red completely changed, and I can now match the other cameras. And so that is the main reason we did these developments there with our own video corrector. It's not really to we're not competing with the other ones. If you're happy with an AJF S4 at that price point, there's nothing else. I mean, you don't need it. If you have all the cameras that are the same, they're going to match somehow. But whenever you're going to mix different brands and models, they are not going to match. That's the nightmare of video engineer.
Well, or even if you're using a bunch of GoPros and they match, you
Exactly.
may not be happy. The grass might be yellow. You still may need to correct.
Or drone. I mean, today you have a drone camera. You want to match that with the other ones, and it's easy with the multi-matrix. You pick the color that doesn't match. As I said, the grain of the grass, the red of the shirts. A concert. If you put a GoPro on a piano and you have I mean, the pianist might have a red dress and it doesn't match the other ones. That's definitely where it helps to quickly add support on that. And also, I mean, let's move to Rio right now, which is the remote production part. So the VP4, I mean, it's a nice picture. I can tell you more, call Jim, and if you need more information about that. But that's 4 channels in and out, and in the goal of that is matching. Now, I want to bridge that with Rio, which is for remote production. So everything that I explained here on the local setup, we want to be able to do that over the internet. And internet means basically latency. Latency on the video, because you need big video buffers to be able to make sure that the video is not going to break up. So you might end up with 500 milliseconds to 10 seconds of latency. And quickly, the bridge there that I make with the video processor, and you might see that in the slides after, but is the fact that the cameras that you're going to use remotely, if I'm talking about an ENG camera, I might not have all the processing built in to be able to match another type of camera. So you might still be happy to have the VP4. And the VP4, if you put that not on the camera side, but on your studio, your facility, the master control room, what is different is that you won't have latency. Let's say you want to adjust the black, the white balance, because that's applied in the studio. That's after the latency on the video. So if you want to change the arrays, there's no way. You have to do that on the camera side, and you will have the latency of the video. But if you want to do some small adjustments afterwards, using a VP4 in post-production is actually a very good solution. The people that tried it definitely saw the advantage of that, is that you have the feeling of having a base station, a CCU, you fine-tune the white balance, you have the immediate feedback. You don't have to wait that 1 or 2 seconds. So it's still good to have camera control, but it's like another layer of adding value in this kind of whole remote production thing. So remote production, what is it? This is controlling the cameras over the internet, and so over latency network. So we still have the RCP, we have a network in between, and on the left side we have the Rio unit. The Rio is like the CIO, but extended to have its own software. There's all the software runs on the Rio as well. And the reason for that is that if we have latency between the Rio and the RCP, then it doesn't matter. We deal with the latency. The camera is only talking to Rio. It's not talking to the RCP. So if we want to add gain to the camera, the RCP is going to send a single command, say, increase the gain by 3 dB. And then the Rio will just change that to whatever the camera is talking, so to the camera protocol. And so if you need a lot of let's say you need to change 10 settings to be able to apply one, you can do that instantly. You don't have the latency that you might have between the Rio and the RCP. And here I'm talking about data latency, so the control latency you might have, which is not 500 milliseconds to 1 or 2 seconds. It's smaller than this. We're talking about 10 milliseconds to 100 milliseconds, I would say, in the worst case. But even though that sounds like I can deal with that, it doesn't matter if I have 10 or 100 milliseconds delay on my settings. It's not true. Some of the protocols will just give up after a certain amount of latency.
It'll time out. Like you said earlier, if the camera can't talk to the RCP or the CCU, it'll time out, it'll fall apart. So
Exactly.
you were telling me yesterday, David, that the Rio actually is its own RCP, or the Rio is kind of emulating or spoofing the RCP. Some of our other vendors do something similar, like our wireless partner AB on Air. They spoof the controller, so the camera thinks the RCP is right there. It thinks the Rio is the RCP, correct?
Exactly.
Yeah, yeah, and
So in that
that's
case,
part of the magic.
in that case, all the protocols that we support will still work over the Rio, because again, what we send from the RCP to Rio is this, apply a 3 dB of gain, or move to the right that pan head, or I mean the pan tilt head, or a PTZ camera, and then it doesn't matter which protocol we use on the other end, it will still work. We are basically dealing with the latency network on our side, so that it's completely independent of what protocol the camera is using, or other kind of equipment. We want to switch a router remotely, we can do that. We want to move a gimbal, all those kind of things are basically built in the system. And because the main software we developed in the RCP to control everything is the same running on the Rio itself. And so what can we have in between? We can have a direct Ethernet connection. We can have Wi-Fi, we can have the internet, we can have cellular 4G LTE. It doesn't matter, 2G might still work because the data bandwidth is very small compared to video. It's nothing. It's mainly the fact that today that's 4G or something like this. In the future, we might have also some very, very low bandwidth solutions to go over RF modems, but that's definitely not a short-term goal for us. It's mainly to make the remote productions kind of style working remotely. And when we say control, everything that we control today will be available. And on the left side, I didn't talk much. I mean, we have no time for all that, but we support lenses. When I say lenses, an ENG does already do that. But let's say you take a digital cinema camera, like a Canon C200, and you put an ENG lens on that because you need that for your kind of shots. The Canon camera is not going to control it, but the Rio has 2 ports, and we can control the camera with 1 port and the NG lens with the 2nd port. Or some people do put that on a drone, or on a kind of a robotic system where they have a mini cam and ENG because they need that big zoom range. And in that case, we support all that. Again, if you have a gimbal, we can control that as well all over the internet. Typical applications, and that's where you're involved as well with AV West, is doing remote production of sports, for example, where if you have multicams, that's definitely better when you can match them together.
Right, right. You can see there, David, in his slide, he's got a little USB 4G modem. The PGA has been using the CyanView Rio and RCP. One of the Achilles heels of using a single modem, you mentioned like JVC. JVC has the ability to put a cellular modem on some of their cameras for video and control. But the problem with a single modem is if you lose connection, I believe we've been configuring these modems with the PGA to AT&T. You hit an AT&T dead spot, you lose camera control. So what we're going to show you in a little bit is VidOvation, CyanView, and Avi West, our bonded cellular partner. We've integrated now where we can do a bonded data connection to connect the Rio to the RCP through a bonded cellular data connection.
Indeed, you're, I mean, perfectly right there. There are a lot of situations where that actually works fine, but if you're mobile and you move around, I mean, sometimes losing control is not the end of the world. In some productions, it actually is. I mean, they need that all the time. So it really depends on that. But the need to have bonding for data, and actually to be able to use the same wire, I would say, as the video path, because if you lose video anyway, you don't need control anymore. So it makes a lot of sense.
Right. I
which
mean,
makes everything simple.
there are workflow issues when you're doing bonded cellular. We're doing a lot of at-home production, REMI production, where they just send the camera operators out and everything is produced back at master control. But the video coming in will have anywhere from 800 milliseconds or 0.8 of a second. And if the cellular network is struggling, up to 3 seconds. So the camera operator will see an image on the screen, but it might be a second old. So they have to make small adjustments not to overshoot. It's part of the workflow. You know, there's pluses and minuses of doing at-home production over cellular. It might introduce latencies in the video, but you just have to be aware of it and adjust your workflow accordingly.
Yep. So you see here, I mean, we can also not only handheld cameras, but if you want to put a beauty shot or a mini cam on a pan tilt head, this can be done as well. Just to finish that part, this slide actually just splits that in two. On the left, it's exactly what we explained there. You have a camera operator with this camera and a cellular device to send a video. You add our system, and then that's basically adds camera control. That's all you need. Now there are some other kind of REMI style productions, which it's not only camera operators. They're shipping minimum amount of equipment, but it's still like a lightweight full production. It can be a fly pack, a minivan with equipment there, but you might not have all your operators on site. In that case, it might still be interesting to have control remotely, because some of your crew, I mean, the shading might be done separate, I mean, decently, or the camera operation, camera movements on PTZ. So what we are developing now is a fully distributed solution that I explained earlier. Is the fact that you can have a small production, a local production with an RCP, and different venues with different small productions, and still be able to control that from a gallery, from a studio. Mm-hmm. Or again, put some RCP at different places at home. You might have the RCP at one place, but the switcher, the video switcher, might be at another one, where you're going to interface the tally signals and all that. So again, with that fully distributed solution, I would say we don't know today any kind of the workflows that we will not be able to support.
Well, you were telling me yesterday, David, that it would be common that you need an RCP at the venue. A technician who's setting up the cameras might want to do a rough paint, adjust the blacks and the whites locally, and then hand off to the operator working remotely or working from home or working at home or back in the studio.
Yeah, I mean, let's say that you have multiple video operators doing the shading during the event, but you don't want to send all of them on site. In that case, you still, I mean, are going to have one RCP, so that someone might, during the day, shade all the cameras to put them in the right ballpark, make sure that everything's working. And then in that case, when the event is going to start, you can take the control remotely and have multiple operators that would do the shading of that event. You've seen, I mean, the slide before that was the Rio and then the couple of ports, but you can connect multiple cameras on Rio. We do support tally whenever it's built in the camera. Some ENG camcorders do support it, some don't, because actually camcorders was not necessarily made to be a live camera. Right. It was made to be able to record, and so you have a red LED, but it's actually a record light and not a tally light. So some of times you can just not control it. In which case you just add a tally LED on the side on the second connector, and you put that in the viewfinder, and you still work. We have a picture there of the Sony FS5. We did manage to get tally working on that one, so the built-in tally works. But if you need an LED on the side, you can do it. We have tally on that Panasonic PTZ here on some mini cams, and to ingest tally, that can be done from a dongle on the RCP, or it can be done by the Neo that you see there. It's just a small Ethernet device. You plug it on the network, and then you connect your 16 inputs. Or we are going to support more protocols like TSL and so on.
So you got
And
GPIO, TSL, switcher protocols,
indeed.
all those protocols you can use for control and for tally, etc.
Actually, just like everything, we keep developing things that are necessary. So whenever we come to a situations where we understand what's the best way to do that, that's where we were doing the development, and we did quite a lot. I mean, CyanView is quite well known in some areas, but we have yet to start. I mean, working a lot on our marketing. We basically worked a lot on the R&D. Developing all those functionalities, make sure that people are happy with that. It's becoming major now, so definitely this is going to spread. And the further we go, the better we understand various points, I mean, various workflows on big productions, small productions, remote productions, and we are keeping adding features. So if we maybe just to do a last demo, I will just put that aside. I do have a Sony camera here from a customer that's landed that to make the integration. It's a Sony camera. I will turn it on, and if you so I'm going to do the demo here. Normally the network works, sometimes it drops, but I have that 4G dongle with a SIM card inside. There is nothing else connected to that camera. So you see I have just one wire here. It's actually taking power is the other way around. It's taking power from the camera, so the device is actually powered, and it's going to control the camera. So you just see, oh well, I am a bit too late, but it booted. You have that icon in the middle that says that it's actually connected to our server on the internet. So what is your server?
I see that. It's got the little router with the Wi-Fi, the wireless signal.
Exactly. So if we go back to the slides, we have a relay on the internet. You don't need to do that. You can open ports, make a direct connection, have a tunnel like we're going to explain with AV West. But if you just have an internet access, we have a relay, which means that you, this is actually the case. Your CP is connected on a switch on the internet. I did nothing. And then that one goes internet access through the 4G dongle. And
it auto connects through the cloud relay.
Exactly, it auto connects. I mean, that's been configured beforehand, saying that this is my Rio and the RCP and the Rio should match together. But once this is done, it automatically connects. And so you see that the big number is there. The camera is green on both sides because the control has been there. If I now disconnect the internet connection, I'm going to lose. We can do that after when I will have the demo. I will turn off the camera. You will see that the green icon there goes away and so on. So now this is my camera 9. Oh, sorry, yeah, my Sony camera here. The same applies. I have the green icon. So you see the picture there is blown out. I have iris control on this camera. And the same way I did earlier with the configuration, I'm going to check, but I do believe that it's still configured there. I had the tally on. Yeah, I have the tally here configured on the second port of Rio. So if I put my LED here on the second port, it might light up as well as the other ones. And I can use the, so I did put the LED here on the second port of the Rio, and I can use the RCP right now to just emulate the tally, turn that on. And you see that now I have the tally on the front of the camera here. I have the tally on this LED. I have the tally on the LED of the Rio unit here. And well, you don't see, but in the viewfinder, it's on as well. I mean, on the camera. So tally, I have camera control. So you see the iris is changing. I didn't explain, but whenever we have iris, the mode button here is exposure, because a lot of those mini cams don't have iris. So whenever you change the exposure, it's going to change the iris on this one. If I take a Marshall, it's actually, I have no iris, so it's actually going to change again. but for me, it's still exposure. I can expose the Sony, I can expose the Marshall. I don't have to switch between iris and gain. And also, we have some requests of people asking for a joystick on an iris joystick. And the iris joystick makes a lot of sense if we have one RCP for one camera. And we're working on something like this. But whenever you have multiple cameras on one RCP, then the joystick doesn't work anymore. You're not going to open, and then because it's getting dark, you need to open all cameras. You're going to open and go to the second, and then you're at the end. While here, it's so actually easy to keep your hand on that and switch cameras and put a bit more gain there, put a bit, open that one and so on. And it doesn't need an iris. It's very efficient that way. You have your black control, your exposure. For this kind of cameras, that's definitely actually faster doing that way. As I said, it makes sense to use, that will make sense to use a joystick when you will have 4 RCP and you put your 2 hands and you try to shade 4 cameras at the same time, simultaneously. But when you're going to do them one by one, this solution is actually working very well.
I'm not good enough to shade multiple cameras at the same time. At Saddleback, I have a multi-viewer above me. I cycle through the camera feeds to check them individually. I switch, or I see on the multi-viewer, or the director will tell me, camera 4 is overexposed. I'm convinced the director always wants a camera that I'm not ready with. The one that's overexposed is the one he always wants.
I know the feeling, yeah. We actually have a feature that we thought about that would be to have a kind of tracking, automatically tracking on the RCP, the camera that would be on preview, for example. Or you could have a button or turn that on and off so that if you press on preview here, because I don't need my preview button here, that would automatically call the camera which is on preview.
Oh, I would like that. So I don't need to. So what I would do, I would manually track what's on preview, check that first. But you know, I'm also the director's right next to me, but I'm listening to on the comm. He'll be like, you know, ready 2. Okay, shoot, he's going to go to 2. Let me check that. Wait, ready 3. Wait, I thought he was going to do 2. Ready 3. No, ready 4. And then all of a sudden going to 2. What? You were on 2, 3, 4. You know, so you know, you get used to your director how quickly they call their shots, but you know.
No, I mean definitely. So that's. I think that's it. I mean, we have no latency here on the video. I mean, you have over the webinar, but as I said, if you have latency and it's difficult to do some very small adjustments, or if you have multiple cameras that actually don't match because they are not the same, having a VP4 there on the same setup might make sense, because in that case, whatever is missing in the camera, you can still have it. And for your fine adjustments, you could decide to do that in post. Now, there is one point, and maybe you're going to expand that, talking a bit about AV West, but we worked with AV West to make sure that our solution would go through their data tunnel. And so the way it works is that you have the RCP on that side. Instead of having an internet connection, the AV West system is acting like a gateway and will route all packets from one side to the other. And in that case, we can reach a camera, we can reach a radio unit to control multiple cameras on the other end. I mean, more and more those systems not only have 1 feed, but they might have 4 feeds. So it's possible that you might have a small wired local connection production with 4 cameras, and you just need 1 radio on that side to control the 4 cameras. And I have the 1 and 2 here. Usually we're going to use the radio. That means that the RCP is going to talk to radio, which is going to convert then to the protocol used by a serial camera or an IP camera. This is the way that we can make sure that it works. But sometimes, depending on the latency, depending on the camera, if you have an IP camera, it might directly work from the RCP to the camera. And it works at various degrees of quality, I would say. You still can get control. It will become steppy. Let's say instead of having like 100 different values of iris per second, you will end up with maybe 10 or 2. In that case, you will have big jumps when the latency increase. Some cameras will stop working, some will just drop and come back. A lot of things happens, but some might just work. And in that case, you don't even need the Rio. If you have a data breach, you can directly talk to a camera. But when you never know how the latency is going to evolve, if you start at 12 milliseconds, but suddenly it ends up 60 and it doesn't work anymore, having a Rio there, it's a way to make sure that it's not affected by the latency at all. You might have 500 milliseconds latency and it still works.
So the Avi West data bridge or data tunnel, what it does is it establishes a connection from the studio side to the field. You can configure it so they're on the same subnet, so that assets in the field appear on the network in the studio, like they're on the same LAN, or we can do different subnets, and sometimes that makes sense. You might want cameras in different areas and the remote site on different subnets. So let me take control.
Indeed.
Let me see here. Okay. Bear with me. That should be it. Do you see? No.
Yep.
You see the screen? Okay, good. So VidOvation, we're the master distributor for a very popular bonded cellular brand, Avi West. It's David's neighbor in France. We've been doing a lot of at-home production, REMI production, whatever an acronym you use for it. We've presented a lot of user case studies with Sports Video Group. We're working very closely with the PGA, VidOvation, Avi West, and CyanView. We've been working closely with the PGA. We've done projects with Turner Sports. I like to say VidOvation was instrumental in creating a new category of live reality TV, particularly shot REMI style at-home production, live rescue, live PD. Live PD we're hoping will come back soon. So live sports, live news, live entertainment, but particularly multi-camera. Bonded cellular was really made to shoot a news event, shoot a reporter on a courthouse steps with one camera. Shading becomes less of a problem when you're only dealing with one camera, or you put the camera on auto. Where Avi West really differentiates is for multi-camera production. And what makes Avi West special is with their SST Safe Streams transport, they're able to maintain frame accurate gen lock across dozens of cameras, not 2 cameras, 4 cameras. We have some productions that are using as many as 40 or 50 cameras, and they all are in perfect gen lock and frame accurate and lip sync with each other. So I've spoken about this before, but why do we want to do an at-home production or a REMI production? Well, particularly before COVID, it was a good idea to save money. You didn't have to your skilled workers, your video engineers, your operators, put them on planes, pay for food, pay for travel. You need fewer people. Now with COVID and social distancing, you may not be allowed to have more than a certain number of people on the course or in the production or in the truck. So it saves on personnel, saves on time, and most of our customers, I don't know how it is in Belgium, David, but most of our customers here in the US, saving money is a big incentive. So here's some, I know we're going on more than 90 minutes here, so I'll make this quick. Here are some of the architectures where we bring all the video feeds, all the ISO camera feeds back to master control. There's topologies where they'll switch the show with a smaller truck on site and then send the switched production back to master control. They could be shading the cameras locally or remotely. Many of our customers are doing a hybrid approach. where they don't send everyone on site. Maybe they send half the crew. Instead of sending 3 trucks, they send 1 smaller truck. We leave it up to you, the customers, the production people, to figure out the topology, the configuration that works for you. We work with many customers that don't have a control room. We do the whole production in the cloud. The show is switched in the cloud. We use a cloud production tools. So whatever the configuration, we can help you. And this is the magic sauce of AVIWest, this SST, the Safe Streams Transport. It bonds or aggregates the networks together, up to 11 or 12 connections, 8 cellular, 2 LAN, multiple Wi-Fi. It does ARQ or packet retransmission, high quality forward error correction, load balancing, etc. You can even prioritize a network connection. So if somebody gives you a free internet connection, but you don't trust it, you can set that as high priority because it's free, and the cellular as low priority because you're paying for that. And the unit will, it's never a good idea to turn off your cellular modems, because if you need them, they won't spin up fast enough. It might take 30 or 60 seconds, or an operator has to be there to turn them on. So we prefer you put them on low latency, and then they'll kick in if the primary connection should fail. Here's the slide. We talked about this in some of David's slides, that the AVIWest Stream Hub, or their receiver, acts as the gateway, not only to receive the video, but to route the control packets with the CyanView system, to route it out to the assets out in the field. So you can see here PTZ cameras. In the field, AVIWest has their Pro series. Those mount on the camera. AVIWest was the first bonded cellular provider to put the unit on the camera. They didn't invent that idea. I think the microwave industry was the first to do that, putting a transmitter between the camera and the battery. So AVIWest was the first to do that. They have rack-mounted options to go in your truck or in your master control, and then they have a nice small Air, which you can put on your belt with a clip, or in a small little shoulder bag. Here's kind of close up how to hook up the unit. So if you're using the data bridge functionality to say do camera control with David's product, you got the blue Ethernet connection. Your video would go over HDMI or SDI, and all of this can be transported at the same time. So we can go live HDMI or live SDI video concurrently with the data bridge and camera control and intercom. So we can do all of this, all these functions simultaneously. This is just a quick slide on how to turn it on. You hit the little cloud, you turn it on, you see your data rate. You can see in the unit, there's icons to show you that you have the data bridge or the cloud connection enabled. This slide shows a typical configuration. So the CyanView gear, the controller, would be here on the right on the studio side. And you can see in this case, it's on subnet 10. Then the assets in the field, we actually have on 3 different subnets, A, B, and C. And you can see subnet 1, subnet 2, and subnet 3. And the traffic, it gets routed through the Stream Hub. The Stream Hub is used as a gateway to route the traffic. And the AVIWest technology and the CyanView technology work very well. And VidOvation is representing both AVIWest and CyanView here in the US. So we can help you with your configurations. We have David and his team at CyanView as backup tech support. We have 24/7 support from VidOvation and from AVIWest to make all these things work. You can see here on the Stream Hub side, see the little cloud icon that tells you you have a cloud connection. One common question is, well, if I do the data bridge and camera control, will that impede my video transmission? Well, the AVIWest does give the video connection priority, but it does allow a couple of hundred, I believe 300 kilobits per second minimum throughput for control, which in most cases is enough, but because we don't want to steal too much bandwidth from the video. The video is our main priority. And this is just some more slides of showing you what you can see in the well, I think what this slide is showing, that if you turn the video off, you get a fatter pipe. More of the data connection will, more of the available bit rate, or all of the available bit rate will go towards the data bridge. But then when you turn the live video on, that gets priority. Here's another drawing showing, I guess for simplicity of configuration, David, maybe you could speak to this, using the RCP with the CyanView gateway instead of using AviWest Stream Hub as the gateway. Is just an alternate configuration, or is there a reason why you might want to do that?
No, I mean, the gateway is one of the possibilities, but it's not a gateway in an IP way. I think that this slide should be revised, because normally it should be the Rio on the left, and the gateway is completely optional. The gateway has been developed at first when we needed really a lot of cameras on a single production. I would say here for remote production, when you're talking about 4 to 8 cameras, you don't really need a gateway today. The gateway is a way also to rack that in a truck and have multiple RCP for multiple operators. In that case, that is really the gateway today, is to have a multiple operator, multi-operator workflow, when you might have multiple operators sharing the same cameras and so on. In that case, it's another layer we didn't talk about of complexity sharing. I would say in a simple diagram like this, you don't need a gateway.
Okay.
The RCP is going to use the AviWest system as the IP gateway to reach the Rio on the other end.
I'll get Ronan and Samuel to correct this slide. So yeah, on the left, as you say, the CIO is just serial to IP converter, but it doesn't have the intelligence to go through an unmanaged network like cellular or the internet. So as you said, David, that should be a Rio there on the left. And the gateway is really more of an option for a more complicated configuration. Okay. Yeah, so this is some of the benefits. As I mentioned, we've done numerous at-home productions here in the US, Turner Sports Rider, Championship Leagues, PGA. We've done some live productions with A&E, Fox, Discovery, Live Rescue, Live PD, First Responders Live. Here's some more customers we've worked with. And then this is just a small sampling. NBC Sports, Golf Channel, Sky Sports, Golf TV, Golf Pass, PGA, and Twitter. I should say also, the AviWest technology has won multiple Emmy awards. I got the little Emmy there at the bottom right. We got to work on getting you an Emmy, David. Your technology is definitely Emmy worthy. I know some people. I got some
Maybe
friends.
one day we'll see.
Here's a closer look of the units. So you see here, top left, traditionally AviWest has always mounted their units on the camera. So if you're using a larger camera that uses an Anton Bauer or V-Lock battery, you can mount it on the camera. And then below that, you can put it into a compact little backpack if you're using a camera that does not have an external battery. And then the Pro 3. Then on the right, we have the Air, and there's a little pouch that it goes in. You can wear that over your shoulder, or some customers, similar to mounting the CyanView on the camera, you can mount them together on the camera. The Air has a 1/4-20 mount to put it on a shoe, accessory shoe on the camera. So let me just jump ahead. Another a key feature of the AviWest tech that the PGA and others, Live PD, have found very useful is analog inputs. So like camera control being very important, and there's some shortcomings out there that CyanView helps. I think of myself more of a video guy, but you can't do video without audio. And with Live PD and PGA, having analog audio inputs on the bonded cellular opened up some great possibilities that they could use a shotgun mic on the camera, but then have lapel mics on the talent, on the commentator, that are then fed into these analog audio inputs to give us better audio options. So here's a little bit about VidOvation. We encourage you to reach out to our team. We offer many professional services, including consulting, design and engineering, systems integration, project management, warranty and support. Here are some of the customers we've worked with. We represent a lot of great brands like CyanView, like AViWest, AB On Air for microwave, etc. So we'd love to hear from you folks. If you'd like to get in touch with David, reach out to the VidOvation team. If you have any questions or comments, I think I actually have a conference call at noon, David, but we have a few minutes.
Okay.
I'll check the chat in a second to see if there's any questions. But you can reach me personally at jimj@vidovation.com or call VidOvation at 949-777-5435. We would love to hear from you. Let me just take a look, see if there's any questions. I think we covered everything. Well, thank you so much, David. Thank you for being with us today. It was truly an honor to have you. We may have to take this video and divide it up into maybe 2 parts because we went maybe about 2 hours, but I thank you for the great content and the great knowledge you've laid on us today. Have a good night and thank you so much.
Thank you for having me.
Take care. We'll talk to you soon. Bye-bye.
Sure. Bye.